In this video, we're going to start by looking at basic integration formulas. I'm just going to scroll through this and you can look at some of these. Some of these are pretty basic. Or you have the power rule set up, used for finding the integral or antiderivative of a polynomial. Again, number 5 is a form of the power rule using U. The ones we're going to be focusing on in this video will be formula number 6. If you have the integral or antiderivative of something of the form du over u, the integral is natural log of absolute u plus a constant. Now if it's not possible for u to be negative, then you can leave the absolute value off. Number 7, again, we'll be using this one. The integral of e to the u with respect to u is always e to the u. Now this were an x, e to the x dx, again, this would just be e to the x. So it's just changing the variable. And then the setup we'll be doing here is right here. You have the composite function f of g of x times the derivative of g dx. If we let u equal to g of x, then du would be g prime. That's the g prime. There's a derivative of g of x dx with respect to x. And notice here then we can transform this original function here, integral of f of g of x, g prime with the derivative of g with respect to x, equal to replacing the g of x by u and the dx by du. This is what we're looking for right here. Transform it in this form. So we'll be using basically what's called a U-substitution. And there's many ways to integrate expressions using partial fractions, trig substitutions. In this case will be the general U-substitutions. So here's the deal. When you look at the expression here, so evaluate each indefinite integral. You look at this. You say, well, 2x to the third over 3x to the fourth plus 2 looks like a rational expression. And generally we look, okay, that's going to be partial fractions. But you look for this also. Notice the derivative of the denominator, let's take the derivative, will be 12 x to the third. The derivative of a constant is 0. So we get an x to the third here and an x to the third over here. So that's kind of like this right here, this setup here. So that tells you can use the U, what we call the U substitution. So the U substitution is simply something we use to facilitate the problem. Try to write this in a form that we can recognize. And what I mean there is something similar to these formulas over here. So you try your U substitution here. Now it's possible though that your first choice might not work, but what I'm going to do here is I'm going to let the U equal to what's in the denominator. That's normally what you're going to do. Sometimes the U will equal to an exponent. So here's the deal. We put this U equal to 3x to the fourth plus 2. That's the first thing we do. Select what U is going to equal. And then we take the derivative, and for the derivative on the left side, it'll be just du. You can say du dx. But the dx will come over here on this side. So then they go over here, then the derivative of this is just a regular polynomial, so it's 4 times 3 is 12. Subtract 1 from the x there, and the derivative of a constant is 0, and then we just multiply this by dx. Now the whole idea with the U substitution is you want to substitute this or replace this expression here with an expression involving the variable u. Instead of x, you want to have all u's here. We don't want to have an x here. So here's what we do here. We can just go ahead and divide this out, or solve for dx by dividing by 12x to the third. So dx will be du over 12x to the third. And all I did there is divided both sides of this expression here by 12x to the third, canceled on the right side. I got du over 12x to the third on the other side. That's dx. Then we make a substitution over here. So notice then, the denominator is u. And then for the dx, that's going to be replaced by du over 12x to the third. And then of course we still have a 2x to the third here. The object again is by using this U substitution, we want to eliminate the variable x. So we convert this to an integral involving u instead of x. And you do this in algebra when you're solving some equations. They could be high order equations, and you put it in the form of a quadratic using a U substitution. So now we just say, okay, here x to the third and x to the third, those are going to cancel. And then here 2 into 12 is 6, so this becomes 1/6. So now let's put it all together here. Now 1/6 is a constant, so that can come outside the integral here, like this. And then all we have left inside then is du over u. Now this is one of the formulas we just saw in the first part of the video here. We have the integral of 1 over u du. That's always going to be the natural log of u in its absolute value here. And then the constant just comes along for the ride. That's 1/6. And then we always have a constant of integration. Call it c. And then we go back to the original variable. Once you've made the integration, always go back to the original variable, which is x. So now we can say, okay, this is going to be 1/6 ln. And all you have to do is replace a u by whatever we had. Okay, u is 3x to the 4th plus 2. And notice we have x to the 4th even power. So this can never be 0 or negative. This can never be negative. So we can just leave out the absolute value and just put 3x to the 4th plus 2. Plus a constant. And this is your solution. If you take the derivative of this, it's going to give you the answer that we have over here. Okay, let's go to the next one. This one is even easier. We know the antiderivative of e to the x is e to the x. We know again, I say antiderivative is the same thing as integral. The integral of e to the u, one of the formulas is e to the u. So here, pretty clear cut that we let u equal to 7x. This is a u, and then we say du equals 2, and then take the derivative of this side, there's a 7, and always put the dx here. And then we want to transform this integral to the variable u. And all we have to do here is just say, okay, it's e, and 7x is what u is, so this will be a u. In this case, I have to solve this for dx, so divide here by 7, and by 7. And so dx is equal to du over 7, so for the dx, then I put du over 7, so that just gives me the 1/7 out in front. I take the integral of this, and the integral of e to the u is e to the u. That's one of the basic formulas. And we have the constant, 1/7 here. Constant of integration is, we'll call it c again, and that's basically your answer, other than going back to the original variable. Once you use a substitution, whether it's the standard U-substitution or a trigonometric substitution, you always have to go back to the original variable. This will be 1/7, and u is 7x, so put the 7x right here, plus your constant. And this is your answer. And again, you take the derivative of this, it gives you the original expression during the integral. Derivative of constant is 0. The derivative of a constant times e to the, in this case 7x, is the derivative of the 7x, which is 7, times the constant is 1. That gives you, of course, e to 7x. That's your answer. And you look at this one again, 3x e to the 5x squared. Notice the derivative of this exponent here is 10x, and that gives me this right here. So this would suggest that we use a U-substitution again. And when you look at the problem that you're doing, integrating, if you don't see what to do right away, obviously, if you have a polynomial, those are easy. You're working with the sine or cosine. You should know the derivative and integrals of those. But if you don't see what to do, then look for the U-substitution. So notice here, in this case, just like in the previous one, the exponent of e is 5x squared. So I'm going to let u equal to 5x squared. Now, if this didn't have an x here, then we'd be in trouble here using this method. But here, if I take the derivative of this, so look, du, derivative of that is 10. Basic expression here, 2 times 5 is 10, subtract 1, gives me x, and then of course this will be dx. So notice we have an x, and the coefficient is x. It works. Now if this had been a 10 there, it'd be even easier, but it's no big deal because it's a constant. So this one we just go ahead and say, okay, this is going to equal 2 antiderivative. Let's just make the substitution. So here, the dx, again, I'm going to have to solve here. The dx divided by 10x here. Divide this side by 10x. This cancels out. So I get dx is equal to du over 10x. 3x there. And I have e. And the 5x squared, that's the u. So I just put a u there. So we're making the transformation from x to u. Dx right here is the same thing as du over 10x. And I notice here the x cancels. This x cancels. I'm left with 3/10. That's a constant. So anytime you have a constant, you can bring it outside the integral. So this will be 3/10. And then the integral of e to the u, du. And the integral of e to the u is e to the u with respect to u. So I can just bring this down. E to the u plus your constant of integration. And the only thing we need here then is to go back to the original variable, 3 over 10, and then replace the u by what we set it equal to, 5x squared, plus your constant. And that's the solution for that one. Now the next one, you look at this, you got x, square root of x minus 1. You have to decide again, it's not an obvious one. We can't just put these together, multiply it, and use a basic formula. So we need to transform this to something we can recognize. And again, I point out that when you're working these problems, there is more than one way to work a problem. Now here, you could actually let u equal to the square root of x minus 1, and then find u squared, which will be x minus 1. You could also do this, and this is what I'm going to do. I can let u equal to x minus 1. I'm going to let u equal to x minus 1. I want to transform this to something I can recognize to find the integral. Then du, take the derivative of u with respect to u, and over here with respect to x, that'll give me a 1 on the right side, and you put a dx there. So that means I can replace the du, or the dx rather, by du. So let's look at this then. Integral. So we know the x minus 1 is going to be u. Now we need something for x, but notice from this same expression right here, if I add 1 to both sides, add 1 here, cancels the minus 1, and then 1 on the other side, I get x equal to u plus 1. I want everything in terms of u. So now I can just go ahead and do okay. The x, and I'll put it in parentheses, can be replaced by u plus 1. And then the x minus 1 can be replaced by u. X minus 1 replaced by u, and of course the square root, I'm just going to write it as a fractional exponent, so instead of that, so I can just multiply through, so this will be u to the 1/2, and then the dx can be replaced by du. Now we've got everything in terms of u. Let's just go ahead and multiply here by u to the 1/2, so this will be the integral of u to the 1/2 times u. That will be u. Exponent here is 1, so that's 1 and 1/2, that's 3/2, plus, and then it's 1 times u to the 1/2 is u to the 1/2. This is to u. Now we can use the power root formula for this. Okay, it's like when you integrate x to the second, you add 1 to the exponent and divide by that. So here what I'm going to do is add 1 to 3/2. 1 is the same thing as 2 over 2, so this will give me 5/2. And the rule is to then you divide by 5/2. So when you divide by 5/2, this becomes 2/5 out here. Same thing with the other one. Add 1 to 1/2, that's 3/2. Divide by that, that puts a 2/3 out here. And that's plus your constant. Then I'll finish it over here. Then all we have to do is go back to the original variable. So for the final answer, then we'll have 2/5 and replace the u by x minus 1. Exponent is 5/2. You have 2/3 and the u again, x minus 1. Exponent is 3/2 plus the constant of integration. Now we could find a common denominator for 2/5 and 2/3 and rewrite this as a single expression. So always be aware of that when you're working these problems from a textbook and they give you the answer in the back and it doesn't even look close to what you have. That's what they did. They found a common denominator for the 2/5 and the 2/3, and they factored out a factor of x minus 1 or so and rewrote it as a product. But for right now, that's your answer. Thanks for watching. We'll see you next time.